Hey, Trent. So I wanted to start with wind power. Wind power is a wind turbine like this, and the wind spins it, and the blades, the wind turbine, is connected to an alternator. An alternator, or something like an alternator. Alternators you have in your car. The gas spins the alternator in your car, but in wind turbines, wind spins it. But this is an old alternator. There's a complex or a tightly woven group of magnets and a tightly woven bundle of copper. The magnets spin really fast, and the different charges in the magnets get pushed into the copper and then travel out the copper into the wire. So magnets and copper wire. So that's the basics of a wind turbine. Now, wind turbines do have a generator, but the generator does not store power. The generator generates the power. Things like batteries can store power. Sometimes wind turbines don't have batteries. The big ones don't usually have batteries. They just send the power right into the power grid, and then anyone who needs it can use it. It just goes to cities and different locations, and who's ever home turning on their lights or doing dishes, it's using the power. That brings up an interesting thought. What happens if everyone's at home doing dishes, like at 5 o'clock at night in a lot of locations, everyone comes home from work and they're doing dishes and washing their laundry and watching movies, and they're doing everything at once, everybody. And so sometimes the wind power doesn't supply power at that time, because wind doesn't happen all the time. There are certainly days when it's not windy, and there's certainly times in the day when it's not windy. Also, wind turbines like a 9-mile-per-hour wind, especially the big ones. If it's too slow, it doesn't work. If it's gusty, like fast and then slow, it can damage the generator. So the wind turbines have a mechanism that just shuts them off. So they like a steady 9-mile-per-hour wind to keep them functioning properly. So it's difficult to rely 100% on wind power. You have to offset the power usually with other methods, especially for large cities and a lot of people, because we're all on different schedules and do things at different times. Let's see, what are some of your other questions? Landscape. So landscape is, you're right, no buildings, no trees. Also, big valleys can funnel wind, like the Columbia River Valley in Oregon funnels wind. Also, differences in temperature, like right next to the ocean, the land heats up quicker than the water. So the land gets hot and the hot air rises, and then over the water, the cold air sinks. And whenever you have air moving, hot air rising and cold air sinking, you get wind. Air moving creates wind. So quite commonly on oceans you have wind, and quite commonly in the Columbia River, where wind gets funneled, you have wind. Advantages? Yes. Wind does not pollute. During the construction of wind turbines, to make the steel for the wind turbines, the factories do pollute a little bit, but once the wind turbine is constructed and installed, it's considered green energy. It's not giving off gases or smoke to create power. You don't have to burn wood. You don't have to burn fuel. You're spinning a blade, the wind is spinning the blade and making power. Disadvantages are that it's noisy, and not everyone likes to look at it. Also, it can be noisy in a different way. It can create like a buzz that can either deter animals, make them go to different locations, or sometimes wind turbines like attract animals in. You can attract birds or bats because of the buzzing, which can kill the birds and bats because they fly into the spinning blade. So that's certainly a disadvantage. Humans can affect wind by changing the climate of the area or building a building nearby the wind turbine. Sometimes large patterns of wind can be affected by like melting a glacier or building a whole city, or changing that temperature flow I was talking about next to the ocean. Changing the temperature flow of things changes the air movement, which changes the wind. Large wind turbines can power several homes. And how do they connect people? So wind turbines connect people exactly like what you said. They create jobs and they provide power. Now the jobs are usually in a different location than where the wind turbine is. So the wind turbine's made somewhere and then transported like to Cape Cod. And so the jobs are in a different location than where the wind turbine is. Then once the wind turbine is, let's say, Cape Cod, the power might go to, let's say, Boston. And so the power goes to a different location also. So that connects people over large distances. Now let's talk about the math. So on the math graph, I have speed on the x-axis, which is the bottom axis, and I have power output on the y-axis, which is the up and down vertical axis. And the graph follows an exponential curve. So when you cube speed, you get power. Let me give you an example. Like if speed is 3, you take 3 times 3, which is 9, and you take 9 times 3, which is 27. So the power is 27. So you always have to figure out what the speed is and then multiply by itself 3 times. So if it's 7, it's 7 times 7 times 7. If it's 11, it's 11 times 11 times 11. It's multiplied by itself 3 times. So if you want to try the math again, that'd be great, because learning the exponents is helpful for when you take algebra. That concludes my video for today. Thank you.